All right, today we're doing the percent oxygen in the atmosphere lab. All right, so we're going to do an experiment to figure out what percent oxygen is our atmosphere. All right. Now, our atmosphere is made up of a whole bunch of different gases, but oxygen and nitrogen make up like 99% of them. So all the other gases combined, the carbon dioxide, the methane, so on and forth, account for less than 1%. So the ones we're going to focus on today are the nitrogen and the oxygen. All right, so in this experiment, what I'm going to do is I'm going to take a plastic box, all right, and I'm going to take a candle. I'm going to melt a few drops of wax on the bottom of the plastic box, and then I'm going to put the candle in those melted drops. Now the reason why I put the melted drops in the bottom of that box there is because when I put the candle in there, the melted drops will cool and harden, and it kind of acts like a glue that holds the candle in place. All right. So I got a box with a candle in it like that. Next, what I'm going to do is going to take the box and I'm going to fill it with water, maybe about ½ an inch deep or so. So I have that. Next, what I'm going to do is I'm going to light the candle. All right. Now, when candles burn, they burn oxygen. All right. Candles need oxygen to burn. All right. Next, I'm going to take a beaker and we'll put a beaker over the top of it, as such. All right. Trapping that volume of air, whatever the volume of that beaker is, that volume of air is now trapped and sealed. All right. Now, as that candle is burning, what's happening is it's burning up the oxygen inside that beaker, and there's no place else for the oxygen to come from. So once all the oxygen's gone from that, burned up from that, what's inside that beaker there, it's gone. All right. So it's going to burn until the oxygen's gone, and then the candle suffocates and goes out. Now, something's going to have to take the place of that oxygen. So what takes place of that oxygen is, because the oxygen's a fairer percentage of what air is, something has to take up space once it's gone, is it sucks in water from the side. And the level of water inside the beaker goes up like that. So what I have left then is what's here is the air minus the oxygen, because the candle burned up all the oxygen. So this right here is basically just nitrogen, all right? And nitrogen doesn't burn. The volume here that's now the water, that's the amount of oxygen that was in that beaker at one point. So if I know how much air was in the beaker initially, and I can measure how much air is left in the beaker now, I could use that to figure out how much is oxygen and what the percentage is. All right. So that's what we're going to do here. So here is the setup. All right. And here is my candle. So step one, I'll light my candle here. And get a few drops of wax on the bottom of this. As such. Okay, next, the beaker. Now the beaker that we're going to use here, right there, that is a 250 milliliter beaker. All right. So where it says volume of container in the lab, you can write 250 milliliters. It's a 250 milliliter beaker. All right, next, I'm going to pour water in there. that. All right, next up, we'll light the candle again. Now I'm going to take the beaker and place it over the top of it as such. And we'll watch as the candle burns up all the oxygen out of there and eventually it goes out. All right. Now, the water level went up to all right, so the beaker is a 250 milliliter beaker, but when I put it in there like that, the water went up to the 200 line, all right? So that means that that much of it was the, basically the nitrogen, all right? So 250 milliliter container, I'm left with 200 milliliters of air after the candle burned out. So this whole thing here was 250, and the level it went up to right there was 200 milliliters. So the volume of air after the candle burns out is 200. All right. The volume of oxygen, if this is how much air I had initially, and this is how much air I had after the candle burns out. This is basically how much nitrogen there is. The difference between these two would be how much oxygen there is. So 250 minus 200 would tell me that there's about 50 milliliters of oxygen. Now, to calculate the percent, what I need to do is I'm going to plug these numbers into this formula right there. All right. So, the volume of oxygen was, the volume of oxygen was 50 milliliters. The volume of the container was 250 milliliters. And then you take that whole thing and multiply it by 100. And then whatever answer you get right there, that is what you calculated the percent oxygen of the atmosphere to be. All right. And that's the lab, because your objective in the lab is to figure out the percent oxygen. And once you do that, once you solve that out and get your answer, that answer right there is what we're trying to accomplish. Once you have your percent oxygen done, there's a few questions on the back of the lab, and then that's it. All right, so that is the percent oxygen lab.